Dr. M here. We're going to talk about preparation of esters using acyl halides. You should have viewed the other video talking about Fischer esterification, which is another way of making an ester. And in that video, I gave you a shortcut on how to get your product. The acid should lose the OH, the alcohol part should lose the H, and that's how we're getting the water as a byproduct. Anything else that's not circled here makes the ester. But OH is not a good leaving group, so most synthetic chemists, in fact all of them, prefer having, instead of OH, prefer having a halogen, because that's a better leaving group, because once it leaves, it's gonna make a weak base. Good leaving groups leave to make very weak bases. Of course, you know when OH leaves, it makes OH minus. That's a strong base, it's a hydroxide. But when X, like a chloride, leaves, Cl minus is not a strong base, it's a very weak base, which makes a strong acid, HCl. Alright, so the same shortcut is going to be used. However, if you want to predict the product, the X will leave and the H of the alcohol will be lost. And that's how you're making HX. And the same ester. The R and R primes are alkyl groups of choice in a question. So those are the shortcuts you can use quickly to just get your products without going into the mechanism. But if you ask for the mechanism, it's so simple, it's not hard. First step is the alcohol uses the lone pair on the oxygen to attack the partially positive carbon of the carbonyl of the acyl halide. If this is Cl, it will be acyl chloride. Then the pi bond opens up. You're going to get 3 lone pairs. You know, this oxygen has 2 lone pairs. Once you open it up, a bond has a pair of electrons. You get 3 lone pairs. And the O minus will use one of the extra lone pairs to reform the carbonyl, to form back the carbonyl. And you know X is a good leaving group, so it has to go. And then, so you get it as a leaving group here. So that's a leaving group. And then the leaving group is going to grab the hydrogen here to neutralize the plus charge on the alkoxonium ion, so the oxygen becomes neutral. Here the oxygen is plus charged because it used its lone pair to make a bond between itself and the carbon of the carbonyl. So once the X leaves, the halogen leaves, like a chloride leaves, it's going to come back to grab the H hydrogen here to neutralize the plus charge on the oxygen. That's how you're making HX. That's how you're making HX, and you'll be left with an ester. The general structure of an ester is as drawn in green. You want to have a carbonyl bonded to an oxygen, and those two should be bordered by alkyl groups on either side of the same type or different type. R and R prime could be same or different. Now we're just going to use our shortcut to predict products here. So as I said, the halogen should be lost, the H should be lost during the mechanism. Anything else is your product. That's anything that's not circled is your product, is your ester product. So we just copy it out. Okay, same thing here. The hydrogen is lost, the halogen is lost to make HCl. Then you simply copy out the rest of the structure. Very simple. Just be careful not to lose the carbon count. Okay, the next example, number 3. The halogen is lost, the hydrogen is lost during the mechanism. So you In this case, it's going to be 1, 2, 3, 4, 5 membered ring. Do I 1, 2, 3, 4, 5 membered ring? It should be looking something like that. 1, 2, 3, 4, 5 membered ring. Yeah. Okay. So you get a lactone. Cyclic esters are called lactones. Cyclic esters are called lactones. Same thing here. You lose the Br, you lose the H. This oxygen attacks this carbon. So we have a 6-membered ring. 1, 2, including the oxygen, starting from counting the oxygen. 1, 2, 3, 4, 5, 6. So we have to have a 6-membered ring. Bicyclic structure. We have a carbon there, so the carbonyl has to be 1 carbon over, and the oxygen has to be 1 carbon over, right there. The other structure is HBr byproduct. See, now the last example is slightly different, but it's similar to what we've been doing. Let's assume we have an excess of this guy, and let's assume we have an excess, equal excess of that guy. So that means this guy will react from this side, and another molecule of the alcohol diol will react on the other side, and so on and so on. So if this is too much and that's too much, so we can pretend you're reacting from both sides, and you're going to end up with a polymer. But again, it's just as simple as saying H and Cl will go, H and Cl will go. What are you ending up with? So I'm going to draw the structure that contains the carbonyl, and I'm going to bring my alcohol on both sides. So on the left, you'll get that structure, and on the right, you get this structure from the alcohol. Okay. So this structure is from the acyl chloride, the structure in red is from the acyl chloride, the structure in blue is from the alcohol. But because we have excess of the acyl chloride, the reaction will still go on this side, and the reaction will go on this side. So we don't need to draw a very long chain. The board will not be enough. So we have only to draw the repeated structure. And the repeated structure, in this case, I'm going to cut here where I don't want to show the second piece of the alcohol, because I don't want to repeat the atoms that are involved in the reaction, and I'm going to cut here because I know this H will be lost anyway. So here I'm cutting here because the Cl has to be lost, and I'm cutting here because the H has to be lost. So the Cl that's lost and the H that's lost makes HCl. Okay, so the structure that's left is our repeated unit. We call that monomer for this polymer. So how do we draw it? So we just, where we cut, we're going to put a parenthesis. Okay. And then we're going to put N to denote that this structure is repeated so many times because both of them are excess. And we're also losing N molecules of HCl. For each combination of these two compounds, you lose a HCl, but because we are reacting N times, and like the excess here is N times, or N moles, so we have to have N moles of HCl, you get a polymer. Alright, thank you, keep practicing, and see you soon.